Let's do a quick algebra review. We're going to do lots of algebra. I'm going to start with an equation that we'll use next week. V final is the final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance. In this case, we're going to call the distance x. So this is an equation that we will see next week. We actually may derive it. But for today, let's just say we want to know, supposing we know the final velocity, we know the acceleration, and we know the distance x, and we want to find out what the initial velocity was. Let's say that's a problem we're doing. Then we need to solve this equation for the initial velocity. So we need to isolate the v initial and get it all by itself. Okay, so what I would do is if I take this term and move it over here, then the v initial squared will be by itself. Okay, so the basic rule of algebra, logic and rational rule, is that if you do one thing to one side of the equation, you do the same thing to the other side. So what we do here is we subtract 2ax from both sides. I'm going to put a plus sign there because I'm not multiplying. I'm subtracting, so that's an addition rule. Okay, the slide is a little sloppy. But what happens is 2ax minus 2ax, this whole thing becomes 0. We say it cancels, but it becomes 0. So v initial squared plus 0 is just v initial squared. And if I wrote this out without rearranging it, I would have minus 2ax plus v final squared equals v initial squared. But generally, we like to have the thing that we're solving for on the left-hand side of the equation. And I would rather not lead with a minus sign. So my inclination would be to write this as v initial squared equals v final squared minus 2ax. And now we need the v initial, but we have v initial squared. Whoops, I forgot the square here. So we need to do the same thing to both sides of the equation. To get v initial squared to be v initial, we have to take the square root, the positive square root. And I got to do the same thing to the other side of the equation. Now notice, I can't take it individually. I have to do to the other side of the equation. So this is a common mistake. And this is not equal to the square root of v final squared minus the square root of 2ax. They're not equal. That would be wrong. Okay, so now we're done. The v initial is no longer squared. And the answer is what I have written there. I don't really need to rewrite it, but 2ax. And then if there are numbers for the problem, then the numbers that were given for the final velocity, the acceleration, and the distance would go into the equation. You would put the numbers in with the units and solve. Let's just pretend that we have those numbers. So v initial equals the square root of 2.4 meters per second squared minus 2 times, I'm going to make up an acceleration, 1.2 meters per second squared. You'll learn about this next week. Times the distance, say 3.1 meters. That's all under the square root. And I'm not going to take the time to put that in my calculator, but that would give us some answer, which is a number. And notice the units. We have meters per second squared here, and we have meters squared second squared, so those units add. And when I take the square root, the meters squared per second squared under the radical, the units become meters per second, and you should pay attention to the units as well as doing the calculation.